We are talking about rectangles, and we want to recognize and apply properties of rectangles, and we want to determine whether parallelograms are rectangles. So here we have example 1, and it says, if BE is equal to 6y plus 2, and so we have BE is right here, and CE is 4y plus 2, those two are congruent, so we can set them equal to each other. So our work right here for number 1, 6y plus 2 is equal to 4y plus 2. We can subtract 4y from both sides, and we get 2y plus 2 is equal to 2. Then we subtract 2 from both sides, and we get 0. And we divide both sides by 2, so we get y is equal to 0 for number 1. Number 2, it says, if the measure of angle BEA is 62 degrees, so right here, BEA is 62 degrees, find the measure of angle BAC. BAC is right there. Now, because diagonals of a rectangle bisect each other, we know that, and they're congruent, we know that BE is congruent to AE, so that's an isosceles triangle, so this base angle is congruent to that base angle. Then we can say that all of the angles of a triangle add up to 180 degrees. So for number 2, we can say 180 degrees is equal to 62 plus x, and combine our x's to 2x, subtract 62 from both sides, and then divide by 2, and we get x equal to 59, which also means the measure of angle BAC is equal to 59 degrees. The next one we have is number 3, and it says BD is 8x minus 4. So that is BD is the full diagonal, and AC is the other diagonal. And we know that those are congruent, and AC is 7x plus 3. So it says find BD and find BE. So for number 3, we know that diagonals are congruent. So because diagonals are congruent, we can set them equal to each other and solve. So we subtract 7x from both sides, we get x minus 4 equals 3. Add 4 to both sides, we get x equal to 7. BD is equal to x minus 4, so BD is equal to x minus 4. We can substitute the 7 in for x, and we get BD is equal to 52. And then we know that BE is half of BD, so we can multiply by half, and we get BE is equal to 26. For number 4, it says the measure of angle DAE is equal to 3x minus 10, right there. DAE is equal to 3x minus 10. In BAE is equal to 7x. Find the measure of angle CDE. Well, these two angles are congruent, so 7x and 7x. But we also know that BAD is a 90-degree angle. So we're working on number 4. So for number 4, we can substitute in, and we get 90 is equal to 3x minus 10 plus 7x. Combine our x's, and we get 90 is equal to 10x plus a negative 10. So we add 10 to both sides, and we get 100 is equal to 10x. Divide by 10, and we get 10 is equal to x. We know that measure of angle BAE is 7x, so we can substitute that in, and we get measure of angle BAE is 70, which is also equal to the measure of angle CDE, which is 70. Next, we have number 5, and it says if AB is 6y and BC is 8y, and the perimeter is 40 feet, find y. So because AB is 6y, that means DC is also 6y. And because BC is 8y, that also means AD is 8y. So we can add all those together and set them equal to 140. And so we get 140 is equal to 6y plus 6y plus 8 plus 8y plus 8y. 140 is equal to 28y. Divide both sides by 28, and we get y is equal to 5. Number 8. Oh, number 7. Number 6. Number 6, if AE is 4K, so AE is 4K, and AC, the whole thing, is 8 plus 6K, so that's the whole thing. What is K? So we have to get equivalent values. So we have AE is 4K, so that means EC also has to be 4K because diagonals are bisected. So we can say 4K plus 4K equals 8 plus 6K. For number 6, we can get our like terms together. 4K and 4K is 8K. Subtract 6K from both sides, so we get 8 is equal to 2K. Divide by 2, and we get K is equal to 4. And then number 7, it says that AB is 6 and AD is 8. Find BD. So this is Pythagorean theorem. So I redrew the picture so it's a little bit more clear and labeled the things appropriately. So AB is 6 and AD is 8. Find BD. So a squared plus b squared equals c squared. Substitute the values in of 6 squared plus 8 squared equals c squared. 6 squared is 36. 8 squared is 64. Add those together, we get 100. In order to get c by itself, we have to take the square root of both sides. So we get c is equal to 10, which means BD is equal to 10. Number 8 and number 9 have to do with determining if a parallelogram is a rectangle. So determine whether the parallelogram WXYZ is a rectangle using the distance formula. Well, the only way to tell using the distance formula is to see if the diagonals are congruent. So the diagonals for this particular parallelogram, because it has to be labeled in order, means that WY is one diagonal and XZ is another diagonal. So we have to substitute those values in for the distance formula. So W, the two values are X is -2, Y is 2. And for Y, we have X is 6 and Y is 1. So we use the distance formula and we get the distance from WY is equal to the square root of 65, and we can leave it like that. Distance from X to Z, the X value is 0, and the XY value is -2, and the XZ value is 4, and the YZ value is 5, and we use the distance formula, we get XZ is equal to the square root of 65. So because both diagonals are congruent, because WY is equal to XZ, so WXYZ is a rectangle because diagonals are congruent. Number 9, determine whether the parallelogram ABCD is a rectangle using the slope formula. And the only way that we can check this is we have to make sure that all 4 angles are 90-degree angles. So we have to check the slopes of all the sides. So AB, we have 4 in the y, negative 2 in the x, 5 and 5, and we get a slope of 1/7. CD, we have negative 2 for the y and 6 for the x, and negative 3 for the y and negative 1, so we get a slope of 1/7. So we know that those opposite sides there are parallel, so that's a good start. BC, 5 for the y, 5 for the x. C, negative 2 for the y, 6 for the x. We go ahead and do our math, and we get negative 7. So BC is negative 7. That is really good because we have 1/7 here and negative 7. So that is the opposite reciprocal. So we know that those are going to be perpendicular. So we just have one more to check. And it turns out that that is also perpendicular. So ABCD is a rectangle because opposite sides are parallel and slopes are perpendicular.